Hello everybody, hope you are doing well, you are safe, you are sound, you are healthy. Now let's start with the second class. In the first one we had talked about what? We had talked about the very basics of chemistry, right? That what is chemistry, how they can be classified. I explained you the concept of atoms, molecules, elements, compounds, mixture, okay? Now we are going to know about something else. Now we are going to know about symbols. Today we are going to study about symbols and valencies. Okay, first symbols. What is symbols? Now there are. I told you yesterday. I told you last day that there are 92 natural elements present. Natural elements present, and 26 artificial or man-made elements present. Artificial or man-made. These are made in the laboratory simply. Okay. So out of these 118 elements together, how can we remember these elements? It's very difficult to write down the names, to write down this thing. Okay. So what easier method was tried to be done is that to represent them by something. Initially, it was tried by, the accepted one, I should say, the first accepted one was tried by Mr. Dalton. Okay. By some pictorial representation. Something is represented by circle, something is represented by circle and a dot, something is represented by circle and a dash, and so on. So on and so forth. But it's also very difficult to remember, right? Now someone is circle with a dot, someone is circle with this thing. So it's very difficult to remember. So it had to be changed, and it was changed. So this Dalton's concept was not very satisfactory, and it was changed by Mr. Berzelius. It was changed by Mr. Berzelius. Okay. He told that let us give the names to the elements according to the English name as per their first letter. Fine, he tried with that. Suppose oxygen. He told oxygen is represented by O. Capital, obviously capital. Okay. Hydrogen is represented by H. Carbon is represented by C. Okay. Potassium is represented by P. Is it? No, potassium is not represented by P. Okay. So where is the problem? Suppose copper. How can I represent copper? C. No, because C has been given already to carbon. Okay. So here comes the most important body of chemistry internationally, which is known as IUPAC. That is International Union for Pure and Applied Chemistry. International Union for Pure and Applied Chemistry. They framed certain rules for the symbolization of the elements. What are the rules? The first rule they told is that it is not necessarily the English name, it can be the Latin name in certain cases. Just now I told potassium. Potassium's symbol is given as K because its Latin name is Kalium. Okay? Latin name is Kalium. That is why it's given as this. Gold, suppose gold, it's not G, it's AU because its Latin name is aurum. That is why it's given as AU. Now again, the misconcept. Why this U? I'll come back to this. Again, carbon. What is the symbol? C. Copper. The second rule. Now comes the second rule. Okay. What is the second rule? It says that if two elements begin with the same letter, then we have to distinguish by writing another small letter after that which is stressed in the name. Copper is written as Cu, but this is also, I should say, a Latin name which has come from cuprum. Copper में कहीं पे Cu नहीं है, okay? It has come from cuprum, Cu, okay? Cobalt is written as Co, cobalt, because C had been taken by already. C is taken already by carbon. Okay, fine. Same way, gold. Gold is not written by G because G has been allotted to somebody else, so it is written as Au. Ag, argentum, that's silver, and so on. So second rule is what? Second rule is that if, obviously it can be represented by the Latin names, and the third rule is what? If the same digit is same letter, and I should say same letter is applicable for more than one element, then there must be another small letter added to it. Small letter, small letter, small letter added to it, okay, to represent that particular element. Please remember small letter. Suppose if I write this, don't get confused with this. And this was actually my first experience, and in my teaching life, when I was taking some viva of some student, and I asked the difference between these two, and she was rather much bigger than you, she was in much higher classes than you. So when I asked her this particular question, she was so confused. She didn't study actually, she was not a good student. She told that this is a big carbon monoxide, this is a small carbon monoxide. No. Whenever I am writing the capital letter, means this is the compound, this is carbon monoxide. But what is this? This is cobalt, this is a symbol. There is a difference between the symbol and the formula. This is symbol. Symbol is applicable for what? Symbol is applicable for only one atom, only one element, one atom. So what are the significance of symbol? There are three significances, The first one, it represents a particular element. It represents a particular element, obviously. Yes. Suppose I am taking one example, N. Okay. N is representing what? N is representing nitrogen. Number two, it represents only one atom of it. Only one atom of it. Whenever I am writing N, means I am talking of only one atom of nitrogen. Yes. And thirdly, it tells us about its mass. Whenever I am writing it, it tells us about its mass, so which we slowly learn. It tells us about its mass expressed in gram. Obviously, atom's mass must be very, very small. It cannot be gram. But whenever that particular mass is expressed in gram, in the unit of gram, that is expressed by the symbol. The mass of nitrogen, mass of N, I should say, is 14 gram. Means the mass of nitrogen atom is 14, and that is expressed in gram, means 14 grams. Okay. So this is the significance whenever I am writing N. So what does it mean? That we are talking of nitrogen, we are talking of one atom of nitrogen, and the mass is 14 expressed in gram. Okay, slowly we learn what is this and all. If I talk about Cu, what is the meaning of this? The meaning of this is that we are talking of copper, number one. Number two, we are talking of one atom of copper. And number three, its mass is 63.5. No need of remembering that, 63.5 gram. Okay, no need, absolutely no need of remembering the masses of this, the atomic masses of this. Okay, fine. So that's what is symbol is. Fine. So that's all about symbol. Okay, now please see the table that is given in your book where some common elements symbol are written. You must know this. Okay, very common elements. If you just keep on saying this, suppose if I ask you, suppose, okay, what is this? What is this? This. We'll say phone. No, I'm not asking about the phone. I'm asking about the, suppose what is this? Okay, what is this? What is this? My card. What is this? If I ask you will say gold. No, now onwards you won't say gold. What you will say, that will be very easy to understand it. What you will say, you will say, sir, it's AU. It's AU. So you can very easily remember that because you have the concept clear. Okay. Now suppose some fulchudi, okay, fulchudi is there, na? We use in the Diwali, okay. What is that? You will say, sir, Mg. You won't say fulchudi, you will say Mg. What is Mg? You know, magnesium. That's nothing but magnesium, okay. It's just what is that called? It's just burns in the air and that light comes up. Simple, okay. Understood that? Okay. So like that, if you just express it, but it's just by seeing a piece of coal, you will say what? Is it coal? You won't say coal anymore because we are chemistry student. We are going to say what? It is C. Is it clear? Coal is nothing but carbon. Like that. Suppose something, a piece of iron, a piece of nail you got. Okay, what is this? It's not a nail. It's not iron. It's what? It's Fe. It's Fe. Like that. We are going to say. Okay, so that it will be C. You will see that it will be very easy for you. Okay, fine. Now, next is valency. Just a little bit idea of valency I am going to give today. Valency, and obviously we have to do it in detail. You have to study that in detail from the book. And queries, please, as the lockdown is going on, queries please note down in your notebooks. Okay, whenever we'll meet after the lockdown, I will clear all your queries, and simultaneously not only studying, you study as well as solve the questions from the book. Okay, you have your books, please start solving the questions from your book. Okay, so valency. What is valency? What is valency? Valency is the combining capacity of an element. Valency is the combining capacity of an element. Okay, combining capacity of an element. How much that particular element can combine with other element is the valency. But which element and which element? The standard was taken as hydrogen and oxygen. That was the standard that was taken initially. Whatever I am telling now, that was the very initial concept of valency, which is nowadays no more applicable. Okay, we'll come to that also slowly, but obviously not in very detail. As per your level, whatever we have to know, we will know. Okay. Whenever we are comparing with hydrogen, we are going to see that a particular element combines with how many hydrogen? Combines with how many hydrogen? Okay. That number is the combining capacity of that element. Okay. Suppose, you know, what is the formula of water? You know, H2O. So with how many hydrogen the oxygen is combining? Oxygen is combining with 2 hydrogen. Hence, oxygen's combining capacity is 2, and hence the valency of oxygen is 2. Is it clear? With how many hydrogen atom a particular element has the tendency to combine is called its valency. Now in terms of oxygen, with how many number of oxygen a particular element is attached, a particular element is bonding, particular element is added, okay, twice that number is the valency of that element. Twice that number is the valency of the element. Okay, for example, suppose if I write magnesium oxide, what is the formula of magnesium oxide? MgO. Okay, what is the formula of carbon dioxide? CO2. You see, very easily we can see. How many oxygen is involved over here? 1 oxygen. Double of it, that is 2, is the combining capacity of magnesium. That means magnesium has valency 2. How many oxygen is here? 2. Double that. How much? 4. So what is the combining capacity of carbon? 4. So what is the valency of carbon? 4. Simple. That was the basic concept. But obviously every element does not react with hydrogen or oxygen, so it's very difficult to find out the valency like this. Okay. Afterwards, the concept of valency has been changed in terms of the electrons, in terms of the electrons, Now, the elements obviously forming the compounds in 3 different ways. With other element, it is forming the compound in 3 different ways. Either by losing the energy, losing the electron. Electron, you know what is electron? Obviously you know, right? Atom, you know, at the center what is there? The neutron and the proton is there, and the electrons, you know, are revolving at this moment. You know, these electrons are revolving in certain path. Neutrons are neutral, you know, protons are positively charged, you know, and electrons are negatively charged. That you know, this basic concept all of you know. So when they are losing the electrons, they are formed, I mean they are combining either by losing the electrons or by gaining the electrons or by sharing the electrons If some element is losing one electron, its valence is 1. If some electron is losing 2 electrons, some element is losing 2 electrons, its valence is 2. If some are losing 3, its valence is 3. If some are gaining 1, its valence is 1. If some are gaining 2, valence is 2. If some are gaining 3, its valence is 3. If some are sharing 1, its valence is 1. If some are sharing 2, 2, 3, 3, 4, 4. Okay, it does depend on that. Now the question is that why the elements will lose or gain or share their electron? What is the problem? The problem is nothing. They want to get more stable. The elements want to get more stable, but by either losing or gaining or sharing the electrons. Okay? How they are getting stable? They are getting stable by gaining the last shell filled with 8 electrons or 2 electrons. Generally 8 electrons, in certain cases 2 electrons. This rule of filling up to 8 electrons is called octet formation. So they want to form what? They want to form octet, either by losing or by gaining or by sharing. If they lose, again I am saying, if they lose 1 electron, they are forming octet and the valence is 1. If they lose 2 electrons, they are forming octet, the valence is 2, and so on. Okay, just let us do it with some examples. It will be very easy for you in that particular case. Okay, let's take some example. Okay, for example, suppose if we talk about sodium has got 11 electrons. And I know you know little bit of electronic configuration and you know the basic of it. In the first shell there are 2 electrons. In the second shell there are 8 electrons, and in the third shell there is 1 electron. Right? So what will be the tendency of the sodium? Sodium will try to lose this electron. If it loses the electron minus this 1 electron, then it will gain the configuration 2 and 8. Means the last shell now is filled up with 8 electrons, so it is octet. How many electrons does it lose? It is losing 1 electron. So what is its valency? Its valency is 1. Clear? Magnesium. What is the electronic configuration of magnesium? It has got 12 electrons. So it's 2, 8 and 2. Tell me, how many electrons it will lose? It will lose 2 electrons minus 2 electrons. If it loses, then it is becoming 2 and 8. Again stable configuration. So how many electrons it is losing? It is losing 2 electrons. So what is its valency? Its valency is 2. Okay, let's talk about aluminium. What is aluminium? Aluminium has got 13 electrons. So it is 2, 8 and 3. How many electrons will it lose? It will lose 3 electrons. If it loses 3 electrons, then it will gain the configuration 2, 8. Again octet is formed. So what is its valency? Its valency is 3. So these are happening. These valencies we are calculating by the amount of loss of electron. Now some elements are there whose last shell contains 5, 6 or 7 electrons. If it has got 5 electrons, it will try to gain 3 electrons. If it has got 6 electrons, it will try to gain 2 electrons to make it 8. If it has got 7 electrons, it will try to gain 1 electron to make it 8. If it gains 3 electrons, its valency is 3. If it gains 2 electrons, its valency is 2. If it gains 1 electron, its valency is 1. Let us check with some example. You can understand it better. Okay. For example, suppose chlorine. Suppose chlorine. The symbol of chlorine is Cl, and the number of electrons that is present in chlorine is 17. So let's write down the electronic configuration of it. 2, 8 and 7. Right? 17 are there. So what it will do? It will try to gain an electron. Right? If it gains an electron, then its electronic, so plus 1e, its electronic configuration will be what? 2, 8 and 8. Again, it is having the stable configuration because last shell has got 8 electrons, rule of octet. So what is its valency? Its valency is 1. Right? Let's talk about oxygen. Okay, oxygen. It has got 16. Okay, 16 electrons are there. Okay, fine. Sorry, it has got 8 electrons. Sorry. It has got 8 electrons. 8 electrons are there. Now, 8 electrons are how they are arranged? 2 and 6. Right? So it will try to gain how much? It will try to gain 2 more electrons. If it gains 2 electrons, then it will become what? It will become 2 and 8. Again, getting the stable configuration. Stable configuration by gaining how many electrons? By gaining 2 electrons. And hence, the valency of this is 2. The valency of this is 2. Yes? Let us take another example. Okay? For example, suppose nitrogen. Nitrogen has got 5 electrons in its atom. Nitrogen has got 5 electrons nitrogen has got 7 electrons in its atom. 7 electrons. So what is the electronic configuration of it? 2, 5. Right? So obviously how many electrons does it need? It needs 3 electrons. So it will accept, it will gain 3 electrons and the electronic configuration will become what? Electronic configuration will become 2, 8, which is a stable electronic configuration. Becoming stable by gaining how many electrons? 3 electrons. So what is the valency of it? Its valency is 3. So this is happening by either losing or gaining the electron. Now in general, an atom is neutral. Why neutral, you know? Why neutral? Because the number of protons and number of electrons are same in an atom. Now when they are combining, till now whatever we had seen, either they are accepting or they are losing the electron. If they lose the electron, number of protons, by losing, right? If they are losing the electron, number of proton will be greater than number of electrons. What is the charge of the proton? The charge of the proton is positive. Charge of the electron is negative. So the positive charge is becoming greater than negative charge. So what will be the total charge of the species? The total charge of the species will be positive. If the species become neutral to positive, that particular species is called cation. We call it cation. Okay. So what we saw? We saw the example of sodium. Sodium is losing 1 electron, minus 1 electron, and it is becoming a cation, sodium cation, which we represent like this, Na plus. Okay. And if it gains the electron, then number of proton is becoming less than number of electrons. Yes, because it's gaining an electron, number of electron is getting more. Okay, so if the number of electron is more, what will be the charge? The charge will be negative. And those species of having negative charges are called anions. Okay, for example, here we can see chlorine is neutral, Cl is neutral, but when it is gaining, it is becoming what? It is becoming Cl negative. So Cl is gaining an electron and is becoming Cl negative. Is it clear? Same way, they can also combine by sharing the electrons. By sharing the electrons. Okay, if they share the electron also, the reason is to get octet or 2 number of electrons 2. I'm just taking a simple example of water. Okay, water, So oxygen, oxygen has got how many electrons? 6 electrons. Oxygen has got 6 electrons in the outermost shell, means 2 and 6, right? 2 though in the inner shell. I'm just talking of the outermost shell. Let me just draw it, then it will be easier for you. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 6 electrons are there. Now it wants to become octet. Obviously last shell. These electrons are of last shell. Now hydrogen, 2 hydrogens are there. Each hydrogen has got 1 electron each, right? Each hydrogen has got 1 electron each. It also wants to get stable. But if it gives the electron, it won't have anything. If it gives the electron, it won't have anything. So what they do is that they share. Now you see, these 2 electrons are shared between this hydrogen and this oxygen. Same way, these 2 electrons are shared between this hydrogen and this oxygen. That means these 2 electrons belongs to hydrogen also, oxygen also. These 2 electrons belong to this hydrogen and this oxygen also. So oxygen as a whole, now how many electrons they are having? 1, 2, 3, 4, 5, 6, 7, 8. It is fulfilling the octet. By sharing how many electrons? By sharing 2 electrons from 2 hydrogen. Yes. So its valency is 2. Oxygen's valency is 2. What about the hydrogen? Hydrogen had 1. Now each hydrogen has got 2 electrons in the valence shell. 2 electrons in the valence shell. That is also a stable condition. So how many electrons it is sharing? It is sharing 1 electron only. It is sharing 1 electron only. Okay. So the valency of hydrogen is 1. The valency of the hydrogen is 1. That is how it is sharing. Same way, I can take the example of methane. Methane is what, CH4. Just 2 examples I am saying, and you can see some more examples. You can try some more examples. As I told, please note it down. When we will have the classes, online classes, we are going to do it in the next week. Then you can always ask me the questions. But before that, you must be ready. Okay. So CH4, carbon. Carbon has got 1, 2, 3, 4 valence electrons. Carbon means 6 electrons are there. So it is 2, 4. 2, 4 means last shell. How many electrons are there? 4 electrons are there. So 4 electrons are drawn. Now there are 4 hydrogens and each have 1 electron. 4 hydrogens each have 1 electron. Each have 1 electron. Okay. Now it will share in such a way. Now these 2 electrons will be shared. 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 Now carbon has how many electrons? 8 electrons. How many it is sharing? It is sharing 4 electrons. How many? 4 electrons it is sharing. So what is the valency of carbon? The valency of carbon is 4. Clear? And each hydrogen is sharing how many electrons? Each hydrogen is sharing 1 electron. So every hydrogen has got valency how much? Every hydrogen has got valency 1. So that's the basics of valency, cation and anion. Please study up to here, okay? And then we will have class. I will tell you about the dates and all. We will sit for a class, and whatever doubts is there till here, we are going to discuss about that. Till then, thank you. Stay safe, stay healthy. Thank you so much.